Hello, hello, hello. Welcome back. Another fun video with amazing harmonizing done by me. This is not what the video is about. I just thought that'd be fun. We're not doing hello, hello, hello today. We are continuing to think about fractions and not just fractions, but the quotients of fractions. So what we're doing is we continue to divide fractions. In fact, really today I'm thinking about like how do we just put it all together? How do we put all of this stuff together? So that's what we're going to explore as we come to the end of this unit of math. We are really thinking about what are all the different bits and pieces we've learned? How do we make sense of what, when, and so on and so forth. So let's dive into that and let's just go down that journey. When we really first stepped into things and we really started to talk about fractions themselves, we were looking at this concept of the idea of we have fractions, um, but also how these fractions become expressions of division. With that being said, of what we mean by that is like if we were looking at a fraction, let's say something like 3/4, that literally is the concept of division because 3/4 is saying the same thing as 3 divided by 4. And then again, when we understand this expression, we can really start to understand like what's going on and things like word problems and what the math is going on. Because again, this picture is basically telling us that we are starting with 3 things and they're being cut up into 4 pieces, which really, if you were to do that, you would end up with 3/4 of a piece. Oh, full circle. So, what we can do in understanding that process, we could look at the other way with when given an expression. Let's say we have an expression like 5 divided by 2, and that could be anything, right? There's 5 oranges and they're being split amongst 2 people. How much would each person get, right? Well, again, as we look at this as a fraction, we think what we start with, we're starting with 5, and that's 5, and that is being divided by 2, which is a top-heavy fraction. So I suppose our real answer would be a mixed number, which would be 2 and 1/2. So I suppose if 2 people had to share 5 oranges, they would get 2 and 1/2 oranges each. The ongoing debate of sharing oranges in people. So that was the first piece. So just making sense of that, right? Remembering what an expression is, and remembering what a fraction is, and then remembering the relationship between them. And you know me, I have to do one more. So let's say I have 7/10. That would be the same thing as 7 being divided by 10, which is going to end up smaller than 1 because 7 is smaller than 10. So taking 7 things and breaking them into 10 groups means you will have less than 1 in each group. Cool. Yay. Step 1. From there, right, we dove into this concept of just understanding then what happens when we start to divide whole numbers. So if I was to have something like a whole number like 5, and I was to then divide this 5 by something like, oh, I don't know, 1/3. What does that mean? Well, we did come up with a couple steps to help us. One, we talked about that concept of modeling. And now that we see this as an expression, we know what we're starting with is the first number. And the first number we have is 5, which means I'm starting with 5 wholes. So if I was to model, then I would be literally thinking about drawing 5 holes. 1, 2, 3, 4, and 5. And then from there, this fraction is telling us that each hole is being cut into thirds. So there's thirds, 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 right? So there, we also think that each one of these is a unit fraction. So 1 divided by 3, or 1 divided by 3, 1 divided by 3. Those are all thirds when brought together. That does equal to 1 whole. But within this 1 whole, we see we have 3 pieces. Right? We have 3 1/3 size pieces. And so the same thing over here, the same concept. Again, I have 3 pieces. I've taken the 5 and I cut it into 3 pieces, which again guess what happens over here? 3 pieces. Here, 3 pieces. Here, 3 pieces. And when we count those up, you're going to see we have 3, 6, 9, 12, 15 pieces. And that is actually our answer. Sorry, I like skipped the other steps. I'm like, we have these steps. Step 1, model. And then I didn't do the other steps. Well, I did mathematically. I just didn't write them down. So our second step would be to cut, right? And then from there, we are literally counting the pieces. That would be the third step, count pieces. Now, one thing we have talked about and explored in other videos is this idea of patterns. And what we're noticing is that when we start with a whole number and we divide it by a fraction, well, the pattern tells us we're actually going to have a whole number as an answer. And that's the part that is a little strange and debatable, which is why drawing a model is helpful, because the truth is we don't actually end up with 15 wholes, right? I don't take 5 and cut them into 3 parts and now I have 15 wholes. What happens is I take 5 and I cut them into thirds and now I end up with 15 of those pieces. And you could think about that if you were serving anything, right? If I don't know, here we have well, I don't know, paper, right? This is just a piece of paper, and I have to cut it into 3 pieces. And I actually have 5 pieces of paper. And when I cut them into 3 pieces each, I'll end up with 15 pieces. Those pieces are smaller, but I have them. So that's that piece there. So that was that second thing we explored. And then we move into round 3 of this, and that's flipping it around and thinking about, well, what happens the other way? What happens when I have a fraction, let's say like 1/4, and I'm dividing the fraction by a whole number? And this goes back to the same steps and the same questions and the same processes as before, because we first want to think about our expression and then we just model it. And according to my expression, what I have is 1/4. That's what I have. I have 1/4. And so when I go to model, I'm not modeling 6, I'm modeling 1/4. So I'm literally going to take one whole, I'm going to cut it into 4 pieces, and I'm going to model that I have one of the 4 pieces. And that is true. That shaded kind of gold yellowish color right there, that's all we have. We don't even have a full whole. We don't even have the number 1. We have less than that. We just have 1/4 of it. And so from there, it's the same steps we saw before in the other work, is that I'm going to go ahead now and I'm going to cut, which is that division process. And so what this is telling me is that this 1/4 that I have, I need to cut into 6 pieces. I'm dividing it equally into 6 pieces. And this is a good way to be thinking about when I model this to go with arrays. I've already done columns, right? I've already gone up and down when I made the model. So when I cut, I'm actually going to go left and right with my rows like this, just because it does help me see like what is happening all together here. And so as that piece comes together and we look at what we have, which is again, I guess even this is step 2 is like cut and then like count it. If we were to count this, we now see, well, let's see, I have 6 pieces on this side and 4 on this side. So that's 24 pieces. And then if we look at the model itself, I have 1, 2, 3, 4, 5, 6 out of 24 pieces. But that's not our answer, because that's what this model says right now, because I just created 1/4 cut into 6 pieces. But I'm actually looking at how much is in each one of those groups or those pieces, if you will. And the step that we did there, that's that idea that we distribute. Because the problem itself is saying that I'm going to take these 6 24ths that I have, and I'm going to share them equally with 6 groups. So 1, 2, 3, 4, 5, 6. And in order to do that, that would mean I would have to put in 1/24 in each group. And really, that's what it is. We're really just focusing on this one piece, 1/24, and that's our answer. Which goes back to another model, or sorry, well, it is a model, but another idea of what we've noticed with patterns is that then what we can see is that when we take a fraction and we divide it by a whole number, we'll end up with a fraction as an answer. So we kind of go back here, whole number divided by fraction will get me a whole number. Fraction divided by a whole number will get me a fraction. So that's an important thing to keep in mind with just reasonability and making sense of a story problem, because as you can predict, that's literally what we did next is how do we look at this in real life? Like, how does this all come together? So let's dive into this word problem and break it apart. Okay, now the strategy for the word problems is they're getting more complicated, right? One thing I've said is like, let's just do this one sentence at a time. One sentence at a time. So from there, we'll read a sentence and then we might think, okay, can I then draw a model of it? Or, or probably both. I actually like the model first, but then also thinking after that, like what's the expression? So we know the math we need to do. So let's look at our first sentence. It says a designer has 9 pieces of fabric to make clothes. All right. End. End of sentence. So the first sentence says a designer has 9 pieces of fabric to make clothes. Sweet. Well, let's think about what that looks like. If I was to model that, maybe I'll draw my designer. Why not? They're looking awesome. Now I'm thinking about the 9 pieces of fabric they have. So that's 9 holes. So I'm going to go ahead and draw out and model. That's 5 and 6, 7, 8, 9 pieces of fabric, which apparently in this scenario, the fabric is bigger than the human themselves. They have very big pieces of fabric. Okay, so there's a model in that case. Now it says in our second sentence, we're going to go to our second sentence and we're going to unpack it. And what it says is they cut each piece in half to make shirts. Okay, well, let's do that, right? So I'm going to cut each one of these pieces of fabric literally in half. There I go. And then we look at our final here, and the final thing is our question. It really says, how many pieces of fabric do they have now? Okay, well, this is where the expression can come in, because let's break down what happened here. What we saw occur was that we had 9 pieces of fabric. We ended up dividing them in half. So knowing that expression, when it comes to our answer and the patterns that we've been studying, I'm starting with a whole number. I'm dividing by a fraction. Therefore, I should have a whole number as an answer. So let's look. I got 1 piece, 2 pieces, 3 pieces, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 pieces. And that would make sense, right? Because again, a whole number divided by a fraction ends up with another whole number. We were able to make sense of this story problem one sentence at a time. We drew models and expressions to help us. The last thing I just need is a labeled answer. So we have our labeled answer, and that answer is 18 pieces of fabric. Okay, so that's it. That's it. That's all I'm thinking about today is like putting everything together and making sense of it all. So again, remembering how like understanding expressions, which is what we kind of did in the very beginning of everything, will help us make sense of the kind of math that we're doing. And then if I know that expression, I can turn around and think about how I want to model it to get myself an answer. Am I starting with a whole number and dividing by a fraction? Cool. Well, then the patterns tell me I'll probably end up with a whole number. If my expression tells me I'm taking a fraction and dividing it by a whole number, then cool. I know that reasonably I'm going to have an answer that is a fraction. And then, of course, all of that comes together at the end with our word problem. So that's it. I'm done. Not bad. I think that was done in a good amount of time today. I appreciate the hard work. Remember, as always, keep asking questions. That is the whole purpose of math, to ask questions, explore, and learn. So keep up the great work. We'll see you later.